Hey there everybody, welcome back to the channel. We're continuing this peer review. Summer's actually almost over. It's coming to an end, unfortunately. I just kind of got back from a conference. Felt like, before the summer is completely over, it's a good time to, grab a drink, cozy up with a good book. If you can't find one, then we should consider this masterpiece by Terrence Howard. If you haven't been following along recently to this channel, this is not a good book. You should not read this book by any means. In fact, nobody should read this book. It might be the worst thing ever written. It might be like the worst thing ever created by humanity. It's just awful. I've lost brain cells. I've lost IQ points from reading parts of this book. But I did recently have a poll on my channel. People were requesting for me to go over his chapter on the laws of thermodynamics. Great. Yeah, it went out. I had 86 votes. I said, to the fans out there, the fans of this channel, which again may not get many updates after this because, I'm going to actually go back to work. For those that didn't know, yes, I am a professional educator. But this peer review it's so interesting. It's such a great project to get into for the summer. So go ahead and go grab a drink of your choice. We're going to tear into what Terrence Howard believes the established laws of thermodynamics is. Or at least we'll read his part of that book. Before we completely get into the book, let's take a look at the established laws of thermodynamics, like the real established laws of thermodynamics. And I thought what I could do is ask one of my best friends, ChatGPT. I call her Jeeps. She does tend to hallucinate, but she seems to get things pretty correct about math and science. I feel like I could say that for a number of my friends. Let's see. Let's say briefly summarize. I'm going to say established because that's what he said. Laws of thermodynamics. Let's see. Laws of thermodynamics are fundamental principles that describe how energy behaves in physical systems. I have heard this. There's a zeroth law, and then there's the three laws. So I will give him this. Look at this. First law of thermodynamics, the law of conservation of energy. That seems to be the one that he really likes. He talks about conservation of energy all the time. Energy cannot be created or destroyed in an isolated system. So he misinterprets that. He doesn't say that correctly, and he thinks that multiplying by zero is a violation of the law of conservation of energy, which doesn't make any sense. Let's take a look at the zeroth law. So from what I understand, there's three laws of thermodynamics, but there's this zeroth law, which is just kind of it's almost more axiomatic. The zeroth law states, if two systems are each in thermal equilibrium with a third system, then they are in thermal equilibrium with each other. This law allows the definition of temperature. So again, that's more of a definitive, it's more of a definition than it is a law. It's just kind of defines things. It sounds a lot to me like the transitive property, which I've talked about before, which is if two things are both equal to the same thing, then they're also both equal to each other. Again, these laws and stuff, instead of just quoting them, what we can do is summarize them in our own words. And that's how you know that people actually know what they're talking about when it comes to math and science, because you can explain things in different ways because, you actually understand it. All right, the first law is conservation of energy. We went through that one. Second law, this is the one I'm most familiar with because the second law deals with entropy. And I've been interested in that. I don't really understand it. I've heard that there's a lot of people who don't understand it, but it's basically it's things going from order to disorder and something about the arrow of time. In any thermodynamic process, the total entropy of the system and its surroundings always increases. Entropy is a measure of disorder or randomness. And this law implies that energy spontaneously spreads out if it is not hindered from doing so. Yeah, so that's pretty much what I understood. We're going to fact check this also with Another great source, Wikipedia. Wikipedia doesn't hallucinate, it just gets weird entries by random people that tend to be wrong. But for the math and science stuff, again, math established laws. These have been established for a long time. Wikipedia is actually not a bad source for things math and science related, unless it's some sort of like fringe science or, I don't know, Terrence Howard math or something. All right, third law of thermodynamics. As the temperature of a system approaches absolute zero, that's 0 Kelvin, the entropy of a perfect crystal approaches a constant minimum. It is impossible to reach absolute zero in a finite number of steps. So that is the most... First of all, it's the first that I've read that in a long time because I don't study thermodynamics. I don't teach thermodynamics, so I don't feel like I ever need to look at it. But I do know that things like can't reach absolute zero. Let's go ahead and check in with Wikipedia on the laws of thermodynamics. And see if ChatGPT was telling us the truth. Because usually she is. She's all right. In fact, let's go ahead. Let me say thank you. I call her Jeeps. Say, thanks, Jeeps. You're welcome. Okay. The 0th law of thermodynamics is, again, thermal equilibrium, a basis for the definition of temperature. If two systems are in thermal equilibrium with a third system, they're also in thermal equilibrium with each other. The first law says, again, conservation of energy. So when energy passes into or out of a system, its internal heat changes in accordance with the law of conservation of energy. That seems to be what Terrence Howard is kind of fixated on. He loves conservation of energy. He brings it up like several times. He brings it up like several times in several different contexts in his awful book. The second law, again, deals with entropy. Like entropy is always increasing. I think with the arrow of time, it has something to do with that. I don't know. Again, I'm not a physicist, but I'm kind of interested in this stuff. The third law is, again, let me read it from Wikipedia. Maybe it makes more sense than when Jeeps told me. The third law states that a system's entropy approaches a constant value as the temperature approaches absolute zero, with the exception of non-crystalline solids, glasses. I like glass. The entropy of a system at absolute zero is typically close to zero. I don't know what that means. I'm going to be the first one to say I'm not really sure what the third law of thermodynamics is telling me. I'm not really sure what it's saying. It has something to do with absolute zero. Again, please, in the comments, feel free to enlighten me. Not as how Terrancehoward has enlightened me in part 2 of my peer review, that literally this page or 2 pages here like almost gave me a stroke. I almost had 1 times 1 strokes. Also, as per usual, if you feel like you enjoyed this video at the end of it, I ask you that you actually watch it, and then if you feel like you liked it by the end of it, then I feel like I earned that like. You can give me that like. If you feel like you learned something especially, give me a like. If you found this funny, if you laughed, if you thought it was cool, or that this book was just the most interesting thing you've ever gazed your eyes upon, which is what I feel. Like, how was this written? How was this book written? Like, it's just astonishing to me that this was A, that he wrote it, B, that people let him release this online. Like, either he's got a bunch of yes men around him, or people just hate him. Like, the people around him are just, I don't know, because why would they let him embarrass himself like this? That's what's difficult also about this book. It's not just difficult to read because like a lot of it makes no sense. It's also difficult to read because it's just, you feel so embarrassed for the author. I feel bad for Terrence Howard. I do. but he needs to stop this. This needs to come to an end with his fake math stuff. So, what I was saying was, if you like my content in general, or if you're not familiar with my content in general, it's basically it's been all about Terrence Howard, on this channel at least. But if you think that it's enlightening or funny, or if you enjoy it in any way, I ask that you subscribe. I probably won't update this channel that much when, the school year starts again, because I'll be working and stuff. But I do have a lot of old content on Terrence Howard. So if you like this video, go ahead and check out my other playlists. I did a bunch on his Oxford speech, which was 2017, by the way. So people think that he materialized out of nowhere on Joe Rogan. I'm like, no, he's been scamming people for years. He did his drone thing in 2020 or 2021. Then he went to go try to scam Uganda in 2021. So he's been doing this for a long time. He's an insane psychopath. I may get back to this. I don't know if I get bored or something, but because it's pretty entertaining to me to make these videos. But I mean, wow, this peer review is absolutely in no way an endorsement of this book. I don't think that you should go read this book. By the way, it is freely available online. I'll have the link in the description. If you want to go read this book, if you do, you're going to understand. If you take a little bit besides watching my videos to just go browse this book, you're going to understand why this is. It's just batshit. It's insane. And it's so strange. It's so strange that people let him put this book out there. Anyway, if you like the Terrence Howard stuff, please subscribe to the channel. I would appreciate that. The main reason I ask is that the more likes and subscribes, then I actually get my videos get higher in the YouTube algorithm. People watch them more, and then people enjoy them, and they comment. So please, if you have anything to say, leave a comment. Timestamps are really cool. So if you timestamp part of this video, then I'll know more of what you're talking about. If you have a question or a comment or a concern or constructive criticism. So yeah, let's end the summer right. Let's end the summer off right with this terrible, terrible book. This is an atrocity. This is the worst. Again, let me give you a disclaimer. By reading or listening to me read some of this book, you might lose some brain cells. Your IQ might decrease. It's some of the craziest shit I've ever read in my life. Oh, it is a window into insanity. I don't know why he wrote this book. It has no value. There's no value to this book. I don't know why he wrote it. I don't know what the motivation was. I think he's just kind of a narcissist and wanted to write a book and have stuff named after him or whatever. He wanted to feel important. That's fine. We've all been there. So, again, one last disclaimer. Don't take any of this book as fact. Take all of it as bullshit, because it's mostly bullshit. It's a really awful book. That being said, let's take a look at the chapter on the established laws of thermodynamics. I can't click on something over here because, again, it wasn't important to get its own icon, apparently. But I can get it. So I mentioned that I didn't really understand the third law. But luckily, Terrence Howard understands far less than we do on this topic. And I say we, meaning I'm pretty sure everybody else. So first of all, he starts off by quoting Newton's third law. Newton's laws of motion are not the same thing as the laws of thermodynamics. You know what? I'm going to put this into OneNote. That way I can annotate over it. All right, established laws of thermodynamics. I thought what would be a fun thing to do, because there's a lot of reading. figure like maybe we could do this. Like we could use some highlighters here. So say I highlight something in green. That is saying that I think it's either correct, because contrary to popular belief, like Terrence Howard occasionally gets things correct. But being that this is a science book and it's trying to like, invent new science, I'll also say like I agree. Because if it's a brand new opinion about science, I could say instead of it just being correct, I could say I agree with that. We can use a red, or maybe not a red, but a pink, because that shows up better. To say something is either incorrect, like blatantly incorrect, or that I disagree. Again, since he's presenting new ideas, I can disagree with them. The thing is, it can't end there with Terrence Howard, because he says some things that are not correct or incorrect. They're just confusing. So let's make another color. Let's say yellow. Something that is just downright confusing. Confusing, or another thing he does a lot is he uses undefined terms. If he uses an undefined term, he'll usually put it like either in single or double quotes. He arbitrarily capitalizes stuff again, which is also weird. So let's kind of use this. I'm not going to mark up this entire document, but as we read through, if any of these come up, I'm just going to mark them, all right? Let's do this. All right, if we were to take into consideration Newton's third law of motion, which states, for every action, there's an equal and opposite reaction. That is not a complete thought. All right, so I'll make notes here on the side, but already, this is not a complete thought. It's like an entire paragraph unto itself, right? And it almost seems like one entire sentence, but it's not. It just says, if we were to take into consideration Newton's third law, okay, cool. So bad start, bad start. For if 1 times 1 ever equaled just 1, then two forces or substances will have interacted without any reaction. I don't know why he's understanding this, because, okay, let's mark this. Interacted without a reaction. So isn't an interaction something that happens between two things? So if it's an interaction, that means that it happened for one thing and also happened with another thing, maybe implying a reaction. So he gets really confused there. Therefore, either Newton's third law is fundamentally flawed, or 1 times 1 must equal at the very least 2. Okay, let's mark our first confusing. I'm going to mark this as confusing because he has said over and over 1 times 1 equals 2. 1 times 1 equals 2. Hey, what's 1 times 1? It's 2. Now he's saying at the very least 2. So he's saying not that 1 times 1 equals 1. He's saying that 1 times 1 has to be at least 2. So greater than or equal, or he's not. What did he originally say, that 1 times 1 equals 2? He's originally said that. But now he's saying that 1 times 1 should be at least, at the very least, 2. So greater than or equal to 2. So, contradiction. He has contradicted himself already. I'd like for you to take particular interest in Newton's ideas idea. All right, we also need to mark up just ideas that shouldn't have an apostrophe, right? That's like possessive. This is plural. Let's start over. I'd like for you to take particular interest in Newton's ideas concerning mass and its attraction to other objects of mass. So mass compared to other objects that also have mass. So he's comparing a quality of something to an object which has that quality. That's confusing. Great start here, Terrence. This might take longer than I thought. Within these concepts rests another obvious proof of 1 times 1 equals 2 in nature. Gravity, which directly correlates to the mass of an object, as taught by modern science, is represented through values in our current number system. Gravity is represented by certain values. Well, yeah. I mean, yes, between two massive objects, there's some sort of gravitational equation, which if I do it right now, I'm probably going to get it wrong, but I think we all do know that the acceleration due to gravity on Earth is a negative 9.8 meters per second squared. Right? That's like if you're on the surface of the Earth, that's the force of gravity that's pulling you down toward the center of the Earth because the Earth is so massive. There's another equation about universal gravity, which I don't remember right now. I'm not going to look it up. But yes, gravity does affect things that have mass. Like two objects that are very massive have a gravitational force between them. Examine, for instance, the tedious process of collecting data. Tedious? Oh, I love collecting data. And the arduous task of processing that data. Well, this is why we have computer science. This is why we have programming. All right, so let me disagree with them here. Right? Tedious and arduous. This is not a tedious or arduous process if you use computer programs, which I guarantee you, anyone in any science ever, if they're conducting research, I guarantee you that they are using computer programs in part of that data collection and part of processing that data. Maybe they're writing the computer programs, maybe they have a software person or a software developer that they know that can help them write the programs, but that's what programming is for. Do you recall how the human mind collects bits of information from multiple forms of stimuli? Okay, yeah. All right, let's do the first where we agree. It's green, right? It does collect bits of information from multiple sources. We call those the 5 senses. Cool, good job. Let's also mark that. Let's say he knows the 5 senses. Which, if somebody out there in my comments wants to, like, what level is that? What grade level do you learn about the 5 senses? Because that's what grade level he's functioning at here. It is initially routed from the sensory organ to the thalamus, where it is converted into electrical impulses. Again, I can't really verify that. I don't know much about brain science, but that sounds correct. Those impulses are then converted to chemical structures that represent the data. That's a weird way of saying it. Remember that a chemical is composed of elements, and each element has a particular mass, and mass is determined through a consideration of force. In Newtonian terms, F equals ma. Okay, that's each element. So there's atomic mass, right? Like an atom of helium is more heavy than an atom of hydrogen because of their atomic number. Mass is determined through a consideration of force. Okay, I'm going to say I disagree with that. Mass is determined by force? And then he cites F equals ma, which is that is Newton's second law. Again, he's on Newton's laws. I'm not sure why he says this is laws of thermodynamics, because he's talking almost entirely about Newton's laws, at least so far. But even that is a misstatement, because mass is not determined through force. This is saying force is determined through mass. This is basic. You can say, let's say it like this. Let's say force is a function of mass, right? Maybe I'm getting a little too mathy with it, but that's my background. Like if you have a certain mass, and say you have a constant acceleration. Well, if you change the mass, that's going to change the force, and you can determine force as a function of mass. So depending on the mass, determines the force. He says, depending on the force that determines the mass. Anyway, I'm kind of rambling. This is getting a little bit long. I'm going to have to divide this into parts. There's no way I can get through all of the established laws of thermodynamics in one sitting. No way possible. Anyway, once again, we're going to continue this. I do want to go through the entire chapter because, again, it was requested on my poll. People want to see it. They want to get my take on it. Want to hear me narrate. Which, by the way, Terrence Howard, if you're listening and if you're looking for someone to do the audio book, I'd be more than happy. I would like to do it blind. That way I can burst out laughing as I normally do when reading your stuff. But anyway, if you like that video, go ahead and give it a like. I am planning to continue this, but not right now. So please like, comment, and subscribe below. We'll see you in the next video. Take care of yourselves, everybody.